intermediate level, one from an advanced level. So I guess in defining the area of a circle, it is the area, the space contained inside the shape of the circle. So just like when we were dealing with rectangles and squares, trapeziums, triangles, it's the space contained within it. So in this case, it would be the shaded blue area. The area of a circle, the formula that'll get you to write down in your books, is pi times radius squared. Now, guys, I must stress that you cannot use diameter for this. When we were dealing with circumference, that being the distance around the outside of a circle, we could use either the diameter or the radius. But when we're dealing with area, we must only use the radius. So the point from the center of the circle to the outside, not this distance across being the diameter. So if we were to write that formula shorthand, A equals pi times r squared. That is usually how you'll see it in any formula sheet that you have. So let's get an example done. So let's just say that the radius of this circle is 3.8 meters. What we're going to do first is we are going to substitute that r value, so the radius of 3.8 meters, into where r is here. So same formula, area equals pi times, and instead of r, I've just replaced it with 3.8 meters, and again, squared. I plug that into my calculator exactly as I see it there, and I end up with 45.36 meters squared. I've just rounded it to 2 decimal places. So obviously when we're dealing with pi, it's going to give me quite a number of decimal places, but I've just rounded to 0.36. So that is the beginner example when we're dealing with whole circles. However, sometimes we're going to be dealing with part circles, and the intermediate and the advanced slides here are going to go through examples of that. So what we have here is a semicircle, so a straight line bang through the middle of a circle. That straight line, it stretches across 10 centimeters. Once again, alarm bell should be going off in your head, but the whole distance across there, that's a diameter. We need a radius, because remembering my formula was pi times radius squared. So if the diameter is 10 centimeters, what's the radius going to be? So my radius is exactly half of my diameter. So my radius is 5 centimeters. So must stress. Daddy! 2 seconds, buddy. Sorry, that's my son there. My radius is 5 centimeters. All right, so what we've got is the radius. Now, you'll notice that I've multiplied it by half. Hopefully that should have triggered you to think, okay, well, multiplying it by half because I have half a circle. So area is pi r squared times half if I have a semicircle. If I had a quarter of a circle, so like a slice of pizza, I'd be multiplying it by a quarter. If I had an eighth, I'd multiply it by an eighth. But in this case, we're just timesing it by half because I have half a circle. So I'm substituting my values in there. So remembering my r value, my radius was 5 centimeters. So all that I've done here is gone my r value, I've substituted for 5. So once I've substituted my value, I plug it into the calculator exactly as I see it there. So pi times 5 squared times half, or you can also do 0.5 if you'd like. And I should be getting an answer of 39.27 centimeters squared. Now, I didn't mention it in our beginner example, but when we're dealing with area, make sure that our units are squared. On to our advanced version of finding the area of a circle or part of a circle. You notice that this one isn't exactly a full circle. It's not exactly a semicircle. It's a segment. So part of a circle. 2 pieces of information we need are obviously going to be, well, what is the angle that we're dealing with there, as well as what is the radius. So we remember that a full circle, hopefully we remember anyway, a full circle is 360 degrees. We need to keep that in mind when we're dealing with segments of a circle, because this is my formula that I'm going to use. So area equals pi r squared, but just like we multiplied it by a half for a half circle, when we're dealing with an angle, we need to be able to multiply that by the angle divided by 360. So we're finding the fraction of the angle, the fraction of the full circle. This symbol here, it's called theta. In maths, we often use it for a symbol for an unknown angle. In this case, that's going to be something that we substitute. So the two values that we're going to substitute are my radius into where r is there, and my angle, my theta, I'm going to substitute for 200 degrees. So substituting our values of radius and theta, will be 14. So my radius was 14 millimeters and my angle was 200 degrees. So again, plugging it into my calculator as I see there. So pi times 14 squared multiplied by 200 divided by 360. You'll notice I've put that inside parentheses or brackets, just so my calculator doesn't get too confused. So what that should be spitting out, and again, I've just rounded to two decimal places, is 342.08 millimeters squared. Again, squaring my units because we are dealing with area. So hopefully that should give you a little bit of an insight into how to do some more of the advanced area of a circle sort of stuff. Make sure you email your teacher if you need help with anything.